Questions like the ones in this module are really common on the AP exam. The questions out of the module are very recent, from within the last 5 years. So they usually combine a slope field, which we talked about in one of our Zoom classes, and a differentiation problem where you have to find the solution to a differential equation. And you did that in the last module. So usually it's part A that involves a slope field, and typically you're the one who has to draw the slope field. This question from 2018 is different. They give you the slope field and you have to draw the curve. Well, actually you have to draw two curves because we have to go through 0, 2 and then a separate curve through 1, 0. So I'll start with 0, 2, which is the point right up here. So around this point, all of the tangent lines are horizontal because anytime that y is 2, our derivative, dy dx, is just equal to 0. So there's nothing to make our drawing curve up or down. So we're just going to draw a horizontal line here. What you need to make sure, what you need to make sure that you do is draw your curve, or in this case, draw your line all the way to the edge of the graph. Because, that's not very straight, because they only award a point for this if your drawing goes all the way to the edges of the field. So you have to fill whatever field that they give you. So that's for the point 0, 2. The graph for 1, 0 is a little trickier because there's a lot more going on this side of the graph. There's a few things to notice. This seems to be something symmetrical. The slope field on the right side seems like a mirror image of the left side, so we want our curve to be symmetrical. If I start at this point and I start drawing to the right, then the tangent lines are all going upward and they level off a little bit above 1, so somewhere between 1 and 2, it's going to level off. So if we try to draw this, it's going to look something like this. So we're using the tangent lines as a guide for us. If I try to fill into the left, well, first, if I keep in mind that this is something that appears to be symmetrical, then I know that I'm also going to need to go through -1 on the x-axis, which looks like it would be here. And I would have something that's the mirror image of what I've already drawn. So something kind of like that. Now we need to fill in the space between those two sections that I drew, and I'm going to go back to the right side and try to fill it in. It looks like the graph comes down a little bit and then it curves. It's going to curve back up. Once we hit the y-axis, it looks like all the slopes there are 0, which makes sense. When x is 0, dy dx is equal to 0. So that's where our point, that's where our curve should have its minimum. So something approximately like that, and your graph doesn't have to be perfect, but you want it to be somewhat close to this, and remember that your graph has to go all the way out to the edges of the field, right and left. So part B of this question is a tangent line problem. So we know that we always need a point and a slope for a tangent line. In this problem, we're given the point. So our point is 1, 0. But we do need the slope. So we have our expression for the slope, and all we have to do is plug the point into that equation. So a notation I can use, I can say dy dx evaluated at 1, 0 is 1/3 times 1 times 0 minus 2 squared. So that is going to be 4/3. So our tangent line is y minus 0 is 4/3 times x minus 1. So that is the first part of the question. We need the line tangent to the graph. So there's my line tangent to the graph. We also need to approximate f of 0.7. All that means that we have to do is plug 0.7 into our tangent line for x. I don't need the minus 0, so y equals 4/3 times 0.7 minus 1. And this came off of a no calculator question. Of course, you guys are going to have your calculators this year, so you can just plug that in. that turns out to be negative 0.4 would be the answer to that. And that's it. This question is just like what you were doing in the last module. So we need this particular solution. That means that we need to find the antiderivative. So I have dy dx 1/3 x times y minus 2 squared. And since we have x's and y's mixed up, we need to separate. I would have 1 over y minus 2 squared dy equals 1/3 x dx. It doesn't really matter if you put the 1/3 on the left side or the right side. I just have a tendency to put it on the right side, just because. So we need the antiderivative of both sides. The right side is going to be a little bit more comfortable for you. So the antiderivative of 1/3 x, so I need to go x squared. And then 1/3 divided by 2 is 1/6. And it's going to be plus c. Over here, you could do this with a little u sub with u equals y minus 2. Or we could look at it as y minus 2 to the negative 2. And hopefully we can see, or at least we can follow, that the antiderivative would be y minus 2 to the negative 1. Actually, it would be negative y minus 2 to the negative 1. And if it's not comfortable for you to just make that jump, that is a u sub with u equals y minus 2. So now I have negative 1 over y minus 2 equals 1/6 x squared plus c. And looking at this, we know f of 1 equals 0. That's going to allow us to solve for c. And I like to do that in this step. So if I go ahead and plug that in, I would have, so that's the point 1 comma 0, so negative 1 over 0 minus 2 equals 1/6 times 1 squared, which is just 1, plus c. So 1/2 minus 1/6 equals c. So 3/6 minus 1/6, so 2/6, which is 1/3. So now we have negative 1 over y minus 2 equals 1/6 x squared plus 1/3. And our goal is to get the y by itself, so we need to do some algebra here. I might combine the right side into one fraction just so it's a little easier for my brain to see a fraction equals a fraction. So this would be x squared plus 2 all over 6. And what we can do is either cross multiply, or we could just flip both sides of our fraction. This would be the same as negative y minus 2 equals 6 over x squared plus 2. So y minus 2 is negative 6 over x squared plus 2. And I guess I'm kind of out of space, but last step I'm going to go over here. So y just equals that whole thing plus 2. So negative 6 over x squared plus 2 plus 2 would be my final answer. And that is correct. So that's good. All right.